So today we're having a lesson on roots, and you should have a lesson 7.3 roots and rational exponents in front of you so that you can use that as a guide while we take notes. So what do you know about roots, specifically square roots? So why don't you turn and talk to your neighbor. You can pause the video so you have a sec to chat. What do you remember about roots? Because let's be honest, it's been a bit since we looked at roots. Okay, so maybe you talked about specific examples that you remember, or maybe you talked about a square root, or maybe some of you were like, well, there can be more than just a square root. But we're going to focus on square roots today, which is when a number which produces a specific quantity when multiplied by itself. So let's take a look at the square root of 49 here. So we know, first off, we have this lovely symbol for square root, and then we would say the square root of 49 is 7. And what that's really saying, worded differently, is what number times itself is 49. And I can say, well, 7 times 7 is 49. All right, let's look at number 2 here, square root of 8. This one's a little bit tricky because if I look at something, I'm like, well, 2 times 2 is 4, 3 times 3 is 9. There is no number that by itself equals 8, and that's true. But let's break 8 apart into things that we know that 8 is. So 8 is also the same as 4 times 2, yes? So if I know that 8 is 4 times 2, which it is, I can actually pull this apart and say, well, the square root of 4 times the square root of 2. This is the same thing as above, which is the same thing as square root of 8. Now, I know the square root of 4, 2 times 2 is 4. So I can say, well, that's a 2. And then I have this square root 2 that's left over that I need to multiply it by. Now, square root of 2 is an irrational number. It's really long decimals, and we don't want to deal with that. So in math, we like things exact, as opposed to estimating with a really round decimal and just rounding at some point. So we're going to say 2 root 2. And we're going to leave it as that. Okay, so let's look for some root vocabulary and terms that I'm going to use. So we have a couple of terms here. We have this thing right here, okay, which is A here, and that is going to be our, and I'll actually use a pen now, that's our radicand. Okay, so that's the term there for radicand, what we're going to take the square root of. And then this thing right here is our root symbol. Okay, which is our radical sign. Okay, so root symbol or a radical sign, and then what is under the root symbol would be called our radicand. Okay, so we're going to talk about simplifying radical expressions. So the first thing we need to know is kind of a rule, and that's the first one that I showed you, that the property product of radicals, that if I have the square root of a times b, that's the same as the square root of a times the square root of b. So that is a rule that we can use. Another one is the quotient property of radicals. And this is the idea, if it's the square root of the fraction a divided by b, that's the same as the square root of a over the square root of b. Now these are going to be really important when we start thinking about simplifying. Just like that example that I did where it was square root 8, I used the product property of radicals to go ahead and split 8 into 4 and 2, so it was an easier one to simplify. But the question is, how do I know when I'm done? How do I know when they're simplified? So radical expressions are simplified when the radicand has no squared factors except for 1. Okay, so examples of this would be like examples of a squared factor would be like 4, because, right, that's the square root of that is 2, or 16, or 25. So that would be a squared factor when I'm talking about what is a squared factor. But also, x squared is a square factor. So is x to the 4th, right? Or a to the 16th. These are all squared factors. So the radicand has no square, or the radicand has no square factors. And when there are no fractions in the radicand, okay, when there are no fractions. All right, so let's try some. Okay, so square root of 72. I don't know what that is off the top of my head, so I'm going to start looking at factors of 72. Now, I see 72 and I go 7 plus 2 is 9. Ooh, that's probably a multiple of 9. So 9 times 8, well, that's 72. And since I want roots, I can say, well, 9, I know the square root of 9. 8 doesn't break into square roots, but 8 times 4, 8 is 4 times 2. So if I want the square root of 72, I could say, well, now I want the square root of 9 times 4 times 2. All right, so that's the same as square root of 9 times the square root of 4 times the square root of 2. Okay, well, that's 3 times 2 times root 2. So that's 6 root 2. Now you're probably saying, Ms. Shope, I didn't see that one. I saw this one. 36 times 2 is 72. Yeah, it totally is. So if I want the square root of 72, I could say square root of 36 times 2, which is the square root of 36 times the square root of 2, which is 6 root 2. So it doesn't matter which way I go, I get the same answer. And if I want, I can do a little check. 6 root 2 squared, that square is going to distribute to the 6, so it's 6 squared times root 2 squared. Well, root 2 squared is just 2. So that's 36 times 2, that's 72. Check, we're good. Let's take a look at number 5 here. So I have the square root of x squared times y to the 6th. So I'm going to split that up instantly into x squared and root of y to the 6th. Now, it just so happens that this x squared thing, it would be x times x, right? So x times itself, that's the square root. So that's nice and simple. That's just x. This other one is just a little bit trickier, right? So I need to be able to take the square root of something. So I know that this is, if I think about this, I could think about this in a couple of ways. But I like to think about it like this: y cubed times y cubed. Remember, when we multiply, we add them together, right? So y to the 3rd times y to the 3rd is the same as y to the 6th. Okay, why did we do that, Ms. Shope? Why do we care? Oh, because if we do this, y to the 3rd squared, which is what y to the 3rd times y to the 3rd is, oh, the square root of that is just y to the 3rd. Okay, now if I get nervous and I would like to check that, I can do so. I can say check and square that, and the square is going to distribute here, so x squared. And then remember, when we're doing a power, we're going to multiply, so that's y to the 6th. Right? And that would be what I got over there. Boom. Okay, that would be it. So we've done it. So I'm going to let you try 6 on your own. Now it follows the quotient property, so just to get you started, I just want to remind you that that's the same as saying square root of 25 over square root of a to the 4th. So now that you know that, I want you to solve number 6 and then turn and compare it with your neighbor friend. So go ahead and pause the video, and then when you've got this, you can come on back. All right, after you've shared this with your friend, let's compare. Hopefully this worked out all right. Square root of 25 is 5. And then I would have sat here and gone, well, that's a squared times a squared. So 2 plus 2 is 4. So that's the same thing as saying 5 over square root of a squared squared. Well, goodness gracious, that's just 5 over a squared. Perfect. Okay, so we can do a little check to make sure that we've done all our math properly, because that's always nice. Okay, and I'm going to square this. So that's going to be 5 squared over a squared squared. So that would be 25 over a to the 4th. And check, that is what we started off with. Now looking at number 7, the top looks a little blah. I like the bottom though. So I'm just going to take my numerator and go the square root of 200m over the square root of n squared. Okay, so bottom is really easy. Square root of n squared is just n. This top is the one that's going to cause me some difficulty here. So I'm just going to start breaking this up and going, okay, well, what are factors of 200? Well, I know that 100 times 2 is 200, and 100 is a perfect square, right? So 10 times 10 is 100. So I'm just going to list it like this. And then over n. Okay, so I can split that up into the square root of 100 times the square root of 2m over n. And that would just be 10 root 2m over n. And again, if I want to, I can do a fun little check for this and say 10 2m over n, and I can square this whole thing. So that would be 10 squared times 2m squared over n squared. So that would be 100 times, that'll cancel each other out, 2m over n squared. That's 200m over n squared. Cha-cha, got it. Okay, on to the next. Okay, so now we have fractions. What do we do with fractions? So looking at this, well, actually we have decimals, right? But I'm going to turn it into a fraction to make my life so much easier. So I'm going to look at this and say I went 2 decimal places over. So that means it's going to be 1 over 100 is the same as 0.01, right? Because 2 decimal places, 2 zeros, this is what we did. So I'm going to say what I really need is the square root of 1 over 100. Now if I do that, that's the same as the square root of 1 over the square root of 100, which equals 1 over 10. I could rewrite that in decimal form if I want to, which would be 0.1, because right, we move the decimal over 1. But I like this answer. This is a good one. I can check that. Right? 1/10 squared, 1/10 squared would be just 1 over 100, which is the same as 0.01, so we're good. That's a good check right there. Check. All right, now let's take a look at 9. Why don't you try 9 on your own and then check it with a neighbor friend. So I want you to try 9. I'm going to go ahead and pause the video so you can try it and then talk to your neighbor friend. Okay, hopefully you've tried it, you've talked to your neighbor friend, and now we're back. So let me work through the problem with you. So again, using the quotient rule, I would say square root of 1 over square root of 4 times 6, or x to the 6. So square root of 1 is just 1. And this would be square root of 4 times square root of x to the 6th. So I know the square root of 4 as well. So we know that that is 1 over square root of 4 is 2. And then this right here, I'm going to, again, think of it as x cubed times x cubed, which is 1 over 2 x cubed squared. So that's just overall our answer is 1 over 2, and then this cancels out, and I have x to the third. Again, here's my answer, but if I want to do a little check, I can say this, right, squared, so that's 1 squared, so that's just 1. And then it would be 2 squared x to the third squared. So that's 1 over 4. Let me write it a little bit. I'll write down here. 1 over 4. And then that would be x to the sixth, which is exactly what we had up here. Check, done. So there we go. Nice work, everyone. Your homework tonight is a worksheet. It's called 7.3. I think I wrote homework at the top, but it's simplifying radical expressions. And you can start working on that in class. Have a great day, and I will see you tomorrow.